we present Liberated Gaussian Splatting, a novel Gaussian splatting initialization pipeline to address the degradation in novel view rendering quality caused by SfM point clouds. While 3D Gaussian splatting has achieved impressive results, it relies on high-quality SfM point clouds for initialization. However, SfM is notoriously fragile. In textureless or symmetric regions, it often fails to register correspondences, leading to severe point cloud missing. In repetitive or reflective areas, it produces incorrect matches, resulting in noisy and floating artifacts. As a consequence, the initialization becomes unstable, and the subsequent rendering quality easily degrades. Several point-free approaches have been proposed. CF3D-GS leverages monocular depth priors, but the predicted depth is often biased and cannot optimize camera intrinsics, causing scale misalignment and structural distortion. Instant Splat introduces foundation model priors, but it requires heavy GPU memory and is sparse view specified, cannot handle scenes with hundreds of images. Range-GS explores random initialization for 3D-GS, but the rendering performance is also not competitive. To this end, we propose a two-stage initialization pipeline to reconstruct photorealistic scenes from posed image sequences without requiring an input point cloud. First, we introduce effective depth alignment. We align raw monocular predictions with unbiased rendered depth from a coarse Gaussian model to resolve scale ambiguity. Instead of directly trusting monocular predictions, we ensemble the aligned depth with rendered depth to obtain more reliable initial 3D points, followed by an edge-aware erosion strategy. This produces scale-consistent and geometrically reliable depth for Gaussian initialization. Second, we perform progressive segmented initialization. We divide the input sequence into local segments. Each segment yields an independent local Gaussian model based on aligned depth. Then, the models are merged into a global Gaussian field in a coarse-to-fine manner, which significantly improves robustness and reduces floating noise. Finally, once the initial Gaussians are formed, the remaining optimization strictly follows the original 3D-GS pipeline with no architectural changes introduced. Please see our main paper for more details. We will compare our method with 3D-GS with or without SfM point cloud and Range-GS on several real-world datasets for novel view synthesis, including MIP-NERF 360, AMA and TanksTemple. Our approach consistently yields higher rendering fidelity, sharper geometry, and significantly fewer artifacts, especially in challenging low-texture and wide-area scenes. Moreover, our initialization strategy is generic and can be seamlessly integrated into other Gaussian-based frameworks such as mini-splatting and Gaussian MCMC. This demonstrates that depth-aligned progressive initialization is a universal solution, rather than a model-specific trick. Thank you for watching.